We're going to do today's lesson in two different videos. The first video is just going to be a review of how to use the power rule to find the derivative, and then how to use a derivative and the function to find a tangent line. The second video is going to start to plant the seeds for the connection between the function and its derivative. So if you're really comfortable with finding derivatives using the power rule and comfortable finding lines, you might go ahead and skip this video or put it on twice as fast speed or whatever it is your kids do when you don't really want to watch something. But I definitely recommend everyone watch the second video to start to figure out how we're going to plant the seeds and make the homework make more sense. So first things first, we're going to take a function. Here's a function f of x equals x squared minus x minus 4. I've graphed it here for us, and I want us to use the power rule to find its derivative. And then, once we know the derivative, we're going to go through and find the tangent line for each of these different x values. In this video, I'm only going to do one of these x values. I'll do x equals 3. When we're using the power rule, that's the thing we did last week where we learned where if you take the power on x and multiply it by the coefficient, that becomes a new coefficient, and then we decrease the power of x by 1. It just happens to work out that way. The definition shows us that it happened again and again and again, and you could definitely prove it, but we're just going to use that now without doing all the crazy difference quotient stuff. When kids are starting off with this, it's helpful sometimes when you're looking at a function to throw in ones where they're like hidden ones. So for example, x squared, there's no coefficient on that. It might be helpful for me to think of that as having a 1 in front of it. It might be helpful to think of there being a 1 here and maybe even a 1 on here. The other thing that you guys will get used to, but is brand new for you right now, is when you take the derivative of a constant, the derivative of a constant is always going to be 0. Now, when you're trying to apply the power rule, it might seem kind of weird, but what you can always do when you have a constant is tack on an x to the 0 power. And the reason why we're allowed to do that is because anything to the 0 power is equal to 1. So if I take x to the 0, that's equal to 1. 1 times negative 4, it's still negative 4. And so I haven't changed anything's value, but I've written it in a way where I can think about the power on x being multiplied by the coefficient and seeing how that plays things out. Now, honestly, really, what I prefer is you guys just recognize that when you see a constant value and you take the derivative, it goes to 0. But for now, I'm going to look at it through this lens just to practice it and like reiterate the power rule. So let's go ahead and use that power rule to find f prime. So this x squared term, I'll take this power of 2 and multiply it by that coefficient. 2 times 1 is 2. And when I decrease this power on x by 1, it's just x to the first power. So I'll just write x. I'm not going to write x to the first. No one does that. Moving to the next term, the power here times this coefficient here is negative 1. When I decrease the power on x by 1, it's x to the 0, which means the x's went away. So it just becomes negative 1. And then for this last portion, hopefully you're like constant, derivative 0, don't worry about it. But just to see the rule in action, this power on x is 0 times negative 4 is still 0. And it doesn't really matter what's next, because 0 times anything is going to be 0. So at the end of all this, I know that the derivative of x squared minus x minus 4 is equal to 2x minus 1. This is the function that will let me find the slope of the local linearity. So as we zoom in on any x point and get that straight line, that'll tell me the slope of that line at that point. We can use that to find the tangent line at x equals 3 or x equals 0 or x equals 4. In the homework, I want you guys to do all three that I show you, because I want you to see how that rate of change changes. And I want you to practice drawing the lines. But I'm only going to do the first one right now, because you don't need to see it 3 times. You just need to practice it a bunch so you're comfortable with it. So, when we are finding a tangent line, here's the thing. Over the next year and a half, you guys are going to be asked to find a tangent line 1,000 different ways, with all kinds of different information thrown at you. But a tangent line always comes down to you guys finding the point and the slope. And if you can find the point and the slope, you can find the line. And they have all kinds of fun ways to hide what the point is or hide what the slope is, but you're always looking for those two things. Right now, it's about as straightforward as it's ever going to be. I need the point when x equals 3. So that means I need the y value, and I need the slope when x equals 3. So here's the deal. If I want to find the point, I'm going to use the original function. So down here, I'm going to write the original function because I made it all sloppy up there. X squared minus x minus 4. If you know the x value and you know the function and you want the y value, all you got to do is plug the x value into the original function. So we're going to take this f of 3 to get 9, that's 3 squared, minus 3 minus 4, that equals 2. So if x equals 3, the y value using the original function is 2. And the slope is what I get when I plug 3 into the derivative. That's what the derivative is for. It tells us the slope of that local linearity at x equals 3. So 2 times 3 minus 1, I'm going up here, equals 5. So now I know my point is 3 comma 2. I know my slope is 5. That means my line, which I'm going to write in purple, is y equals slope x minus known x plus known y. That's the equation of the tangent line. And then I want you to graph it by hand because it's good for you and you like it. If I'm going to graph this by hand, I'm going to go 3, 2. So go where the point is. The point's at 3 comma 2. I can get that by looking here, or I can get that by looking here, or I can just look at the graph, frankly. And then the slope is 5. So from this point, I'm going to go up 5. 1, 2, 3, 4, 5, and over 1. It looks like it's on the graph, but it's not. It's just a little bit off. Go down 5. 1, 2, 3, 4, 5, and 1 to the left. And then we're just going to grab a straight line segment and try to our best to connect these points. And we can see that the line looks like it just barely skims that parabola. And if I were able to zoom in on this area really close, that purple line and that blue graph would look almost identical. I'm going to follow similar steps for when x equals 0 or x equals 4. I'm going to use the function to find the y value. I'm going to use the derivative to find the slope. I'm going to get my point slope form, and I'm going to graph. And I want to point out the other thing too. Do you see how I graphed it? Like I went straight to the point. You guys have graphed so many lines by starting at the y-axis and then going up and over from the y-axis. Don't do that. Start at the point that you know. If you know the graph goes through the point 3 comma 2, start at 3 comma 2. If you know the graph goes through, well, that's a bad example. It goes through 4 comma 16 minus 8, then you start at the point 4 comma 8. Start at the point. Don't convert this. Good luck with this part. I think it's going to be a good chance for you guys to really get comfortable with this power rule stuff. You know, we're pulling back some old skills from probably middle school, so it should feel pretty good. And yeah, just keep at it. I'm sure you're doing great. If not, please email me. We had a great meeting with a couple kids last week. It's not too bad at all, so please take advantage, and I'll see you guys later.